Number 8, is that the one you're talking about?
Yeah.
All right. So let's say this is you. Oh, no, that don't work. There. You're running at 5 meters per second this way. And you have a friend here throwing a ball at you at 10 meters per second. And then there's you over here, or your friend over here throwing a ball at you at 10 meters per second. All right? The question is about how fast does the ball appear to be coming at you directly, right? So in the case of this problem, when I look at what's happening between these two people, now if you were just standing still, the ball would be moving at 10 meters per second, and it's clear that the ball is moving 10 meters per second relative to the ground. But you're moving across the ground towards the ball, which is going to shorten how long it takes the ball to reach you. If I wanted to get an idea for how fast the ball appears to be traveling towards you, all I really need to consider is, what do I do with these two numbers? The ball's going to definitely be going faster, correct? So from your vantage point, the 10 meters per second ball is moving faster than 10 meters per second because you're moving through the space at 5 meters per second towards the ball. Now imagine if the ball wasn't moving at all. If he was just holding the ball and you were running towards him, how fast would the ball appear to be moving from your vantage point?
He's just holding it.
What's that?
He's just holding it.
He's just holding it.
He's not moving.
It's 0 relative to him, but is the ball getting closer and closer to you as you run towards him?
Should be 5.
It'd be 5. If he throws the ball towards you at 10 meters per second, do you see how that's going to add an additional, it's going to close the distance between you and the ball much faster. And the relative speed between you and the ball would now be 15 meters per second. Because the ball, if you were standing still and the ball was thrown at you, you would see the ball traveling at 10 meters per second towards you. We add those two things together because you're moving towards the ball while the ball is moving towards you. Does that make sense? So can you do a similar kind of argument for what's happening here?
Should be 5 for him.
Yeah, 5 meters per second. It is approaching you at 5 meters per second. And these would be considered the relative velocities of the ball compared to your motion through the system. When you're moving and they ask a question like this, it's like they want to make you believe you're stationary and things around you are moving. All right, so that's question number 8. Question number 9, consider the problem again. This time, you measure both balls to be 10 meters per second while you run at 5 meters per second. How fast was each ball thrown? So now that's a different thing. You're still traveling at 5 meters per second. But the ball coming up behind you, we don't know its velocity relative to the ground. And the ball coming towards you, we don't know its velocity relative to the ground. But you appear to see them traveling at 10. Taking your speed into account, can you use the same kind of rationalization to figure out how fast this ball must be traveling for the combined speed to be 10 meters per second?
Yeah. Lower than front has to be 5.
Yeah.
And lower
Excellent.
in the back has to be 15.
Yep, that's exactly it. Good job. Make sense? Excellent. Let's say the runway is right here. And in order for the plane to land, the plane has to be traveling due north to be able to match up with the runway. But the wind is a cross breeze, and it's pushing the plane in such a way that it's going to try and push it off the runway. If the plane were to try and travel just due north, do you realize that it would be unable to make it onto the runway because the wind will blow it off the runway? Yes, sir.
I have this. I got it once because I got it once.
That's fine. Did you print this out?
No.
You don't need that. Thank you. I'll take care of it.
This,
Thanks for getting your So we have to try and figure out what direction the plane has to fly in order to successfully make it down the runway. Now, I think most of you probably realize the plane's going to have to fly somewhat in that direction. The issue comes down to, well, how much in that direction would it have to fly? And that's where the problem comes down to. So this problem is pretty tough if you don't know what to do. Let's see if we can't reason our way through what has to happen. The process for solving this isn't any different than before. We're still going to convert our problems from polar to rectangular. We're going to add up our like components, and then we'll convert back to polar. The difference is that we don't really know the direction of the plane. So let's just say the plane's going to have to fly that way. And we'll say that this angle is theta, and this is 150, but we don't know what theta is. It doesn't change the process at all. It merely means that theta has become the unknown, and our process still has to work in order to figure out what theta is. Now, I'll be perfectly frank. If you had trouble with the stuff before, you're not going to be able to do this particularly well. That's why I say it's like level 3. I'm trying to see what you are capable of doing. This won't be on your test. They don't ask questions like this. But, and I'm going to say this very clearly, this is within your abilities, or should be. Does everyone understand? I don't want to spend another week trying to teach every one of you how to do this when I know it won't be on the test. I'd rather use that time for something else. But if you can't do this, there's going to be some stuff we do in forces that will be more challenging for you. So the reasoning I'm going to use here is reasoning I expect you to be able to handle. So let's talk about what we should do first. I want to remind you that I'm not going to change the process. I'm going to draw a right triangle that wraps around my angle. That's my first process. And I'm going to say that the plane is 150 kilometers an hour. Oops. Let's fix that. Maybe. There we go. And it's theta degrees, in this case, east of north. And I'm trying to convert it to something in the x direction and something in the y direction. When I look at that triangle over there, I say that this is the opposite side, this is the adjacent side, this is my hypotenuse. And I've reached a point now where I don't feel like writing everything out. If you have to write everything out, then that's good, do so. But I can look at this and say that the opposite is going to be 150 times the sine of theta, and the adjacent is going to be 150 times the cosine of theta. Now, you might need to write out sine theta equals opposite over hypotenuse, and cosine theta equals adjacent over hypotenuse to reach the same conclusion. You can understand why I'm kind of done doing that. So you need to catch up to me. The opposite appears to be in the x direction, so I'll say 150 sine theta in the x direction plus 150 cosine theta in the y direction. I know I don't know what theta is. It's okay. I'm going to keep trusting the process. 50 kilometers an hour is the wind. 45 degrees south of west. I'm going to wrap a triangle around the wind vector. Now, I've been doing these on separate diagrams. I'm doing them on the same diagram to just conserve our time. But either way, I still say this is the opposite, this is the adjacent. And seems to me that the opposite is going to be 50 sine 45, and the adjacent is going to be 50 cosine 45. I don't know what those are, but sine of 45 equals cosine of 45, and that's 0.707. So these are about 35 kilometers an hour with some change. Could somebody work that out for me and tell me how much? Excellent, 35.5. So that means this is 35.5, and that's in the negative x direction. And this is 35.5 in the negative y direction. You doing okay so far? Any question about any of the things I've done here? All right, so far I've stuck with the procedure. Yes, sir?
Would I be off if I got 35.4?
No, probably a little different than this. But off, I don't know. I didn't actually punch this into a calculator. I took your word on it, or whoever's word. If it were me, though, I would keep lots more decimal places here. You have a calculator. You can probably keep a lot of decimal places between steps. So I would keep as many decimal places as you possibly can. Now, this is the part that's going to take your active conjecture. And if you don't understand what I'm about to tell you, it's going to be hard for me to convince you. But if I want my plane to travel along the ground so that it's traveling due north, then I want the combination of these two vectors to have no component in the x direction. I want this sum to equal 0. You guys follow what I just did? I want that sum to equal 0. That way the ground speed of the plane has no component at all in the x direction. Its only velocity will be in the y direction. Well, that means that 150 sine theta minus 35.5 has to equal 0. This provides me a direct pathway to figure out what the angle has to be for the plane. I'm not sure you would have thought to do that. But now that you've seen it, my suspicions is that that wasn't too tough. If you want to fly down the runway, then you need to ensure that you have no component that is off axis. And this is what you would do. Now, I can continue if you'd like, because that doesn't answer the question. It gives us part of the question. It tells us the angle the plane has to fly to successfully land. It doesn't tell us what the ground speed of the plane is, which is what we would have to do next. So we will need to find out what this angle is, which is the inverse sine of 35.5 divided by 150. I don't know what that is. You should figure it out. Or not. What is that? Really? It's 0.2? 13 degrees sounds about right to me. Now, whatever angle you actually get, I'd keep as much change as you have as possible here for the next portion, but this will get us our angle. Ready to move on for the next part? Well, the next part is merely understanding that the sum of the y-coordinates is going to be the ground speed of the plane. The plane has no component in the x direction, so its entire ground speed is whatever the sum of the y direction is. So now that I have my angle, I can figure out that sum. So the y direction will be 150 cosine 13 degrees minus 35.5. That sum will be the ground speed of the plane as it travels along the runway. Questions about that? So I've got a river or something. And we don't know the speed of the boat in still water. but we know that it's going to travel, all right, it's going to travel 30 kilometers downstream. So if that's the direction of the water, and it's going to travel, say, from here to here, and this is 30 kilometers. So this is the boat traveling that way. And let's see. All right, so we don't know the speed of the water, so let's say velocity of the water and the velocity of the boat. It's going to travel 30 kilometers downstream. It's going to take 3 hours. This isn't an acceleration problem, so we can say that the distance the boat travels equals the velocity times the time. Is that okay so far? Now, in this circumstance, and it travels downstream, the velocity of the boat relative to the shore is the velocity of the boat plus the velocity of the water. Right? So it's going with the current of the water. And we know that it'll travel that 30 kilometers in 3 hours. Everybody okay so far? So that means the velocity of the boat plus the velocity of the water equals 10 kilometers per hour. So when the boat travels backwards, it travels 5 hours. It takes 5 hours to do the same trip. So under this circumstance, the boat has to travel 30 kilometers, but this time it's the velocity of the boat minus the velocity of the water, because it's traveling against the current, and it takes 5 hours. Is that okay so far? So 30 divided by 5 is 6. Still okay? 2 equations, 2 unknowns. I can figure out the velocity of the boat from there. You kind of looked at me quizzically, but I get V boat plus V water, and 6 equals V boat minus V water. If I just add these 2 equations together, the negatives cancel out, and I get 2 times V boat, and 10 plus 6 is 16. So the velocity of the boat has to be 8. Looks like the velocity of the water is 2, if you needed that. So take and just distribute the 3 here. I get 30 equals 3 VB plus 3 VW. You have X and Y, but I have different placeholders, right? I knew I was going to have velocity plus velocity and velocity minus velocity. It made it easier for me to do the row echelon elimination, or whatever you guys call this, when you guys have 2 equations with 2 unknowns and have to solve it. It was just easier if I knew they had all the same coefficients. I'll start recording now, so when parents listen, I don't sound too terrible. Here's my river, and I have starting point and ending point. And if I started from here and went this way, and it took 3 hours to go to here, the 30 kilometers, then I'm pretty sure that that meant that the current was that direction while I was traveling there. Does that make sense?
Yes.
All right. And this took 3 hours. So then I turned around and went this way, but this way went 5 hours. Any acceleration involved? No. Right? Constant current, constant speed of the boat. Good so far? If I'm the person who's standing here and I watch the boat, then when the boat leaves the dock, there's the velocity of the boat plus the velocity of the water. It's got both. It's going, because it's going in the direction the water's pushing it. Since distance equals velocity times time. The velocity times 3 hours had to equal 30 kilometers. Then the boat turned around and came back. Well, this guy over here watching a boat would see the boat fighting against the current. Speed of the boat minus the speed of the water is probably what he saw. Right? Going slower compared to the shore now. And it took 5 hours to go 30 kilometers. That's 2 equations and 2 unknowns. Find the velocity of the boat. Right? That's it. Now, even now, though, I watched people do this in first period, and I was sad. So try it real quick. I'll give you 60 seconds. And if you don't know what I'm asking you to do, again, thoughtfulness. But I see 2 relationships that have the same variables in them. I think you have methods. "45 seconds. You're all busy just writing it all down because you didn't write anything down before. I know, it takes a long time. That leaves you 30 seconds. We done yet? It's not terrible. Anybody who distributed the 3 and the 5 did it wrong. It could be done that way, but that's not the best way to do it. Because this one is velocity of boat plus velocity of the water equals 10. Right? Divide both sides by 3. And here, the velocity of boat minus the velocity of the water equals 6. Right? So if I just add these 2 equations together, that cancels out, and I'm left with 2 times the velocity of the boat equals 16. So velocity of the boat equals 8 meters per second. That's it. Current must be 2. When I travel with it, travel 10. When I travel against it, traveled 6. In this particular problem, try and let's do everything probably on this one grid. We're told that the plane can fly 150 kilometers an hour, but they don't give us a direction for the plane. They do, however, tell us that the wind is blowing this way, something like that. And that it is 45 degrees south of west at 50 kilometers an hour. We good so far? Now, we're told the plane needs to fly due north, probably because it's going to land on a runway. And in order to land on a runway, the plane has to travel in such a way that it only travels in the direction of the runway. This problem's a little different than the other ones where he just said pointed the plane in one direction and the wind was in another direction, you added them together. But that's probably not how you would like to fly somewhere. I mean, if you want to go from here to Atlanta, a major hub, by the way, and the wind is blowing to the east and you fly towards Atlanta, you will not land in Atlanta. You might land in the Atlantic. So you want to fly into the wind a little bit, correct? Because you know the wind is going to push you back on course. So I think we probably want to fly, something like this direction, right? Flying into the wind. Truth is, I don't know how much to fly in that direction. I know the plane can fly at 150 kilometers an hour, but I don't know what angle to make. Now, I'm assuming you guys have the thoughtfulness to understand the plane needs to fly in the first quadrant for this problem. If you don't have the thoughtfulness for that, you're not going to be able to do this question. But now I'm going to proceed with the procedure I gave you, knowing I don't have the angle. I know the plane is 150 kilometers an hour at an angle of theta, and that's just east of north. I'm going to convert that into something in the x and y direction. And I have the wind, 45 kilometers an hour. This one I know a little bit better. It is 45 degrees south of west. Pretty sure I'll be able to do some conversion here. I'll be able to convert that one into its rectangular. So let's do that one first, since I have all the info, and as thoughtful as I'd like to be, perhaps, doing something that's rock solid will help. So I'm going to draw my triangle, wrapping it around my vector. Still have people who can't do that. Look, angle, and there's a triangle right there. Draw the first arrow along the coordinate system. And then when you get to the edge there that's lined up with the arrow, draw a perpendicular. This is my adjacent side, my opposite side. And I'm a little bit done with the whole writing out sine, cosine, and tangent for everything. I'm going to have to start expecting you guys are acclimating to this. So the opposite side is 50. The opposite side is 50 sine 45. And the adjacent side is 50 cosine 45. And since sine and cosine are both the same, I only need to do this once. I think it comes out to be like 35.5 or 35.4. I'm not sure which. You should keep lots of decimal places. But I'm going to put 35 in the x direction and 35 in the y direction. And that's quadrant 3, so that's negative x and negative y. Any question about that? Alrighty, I'm not going to change my procedure. I'm going to draw a component in that direction and a component in that direction. I'm going to label this the opposite side and this the adjacent side. Now I'm going to get an expression for the opposite and adjacent side. Using sine equals opposite over hypotenuse. 150 sine theta is my opposite side. And 150 cosine theta is my adjacent side. I don't know what theta is, so I can't get a number here. But I can still write out my ratios. Remember, in this problem, the angle is the unknown. So having an unknown here shouldn't surprise you. Again, thoughtfulness. So I will press on. 150 sine theta plus 150, the stuff's in my way, cosine theta. I have successfully converted my vectors from polar to rectangular. I don't have numbers for the plane, but I have expressions for the plane. Any question about what I've done so far? I have not veered from our procedure at all, have I? I've done the procedure exactly as we discussed. Sometimes, though, you have to know when to veer from procedure. I'm still going to add these together, but I need to be thoughtful. If I want to land traveling due north, then that tells me something very specific. It tells me that my result has no x component. Do you understand why that has to be true?
Yeah.
I want to fly due north, so I can't be flying at all to the left or right. Well, that's the answer then. That means that sum has to equal 0. 150 sine theta minus 35 has to equal 0. There it is. That's how you get the angle. Now, that's not the answer to the whole question, but it does tell you what theta is, which ends up being like 13 degrees. And once you have the angle, you can figure out what the y component's going to be. That's your ground speed, which is the second part of the problem. I'm not going to do that part. I think if you can make it this far, then you could probably make it that far. I'm not saying that to be cruel. I'm saying that because I need you guys to bring something to the table here. The procedure was the same. Now, by the way, when you do this part and you say, okay, 150 cosine 13 degrees minus 35, this is going to equal your component in the y hat direction, but there is no component in the x hat direction. So this will be the ground speed of the airplane due north. You knew the direction of your answer from the very beginning. Now, question 7 is the exact same question, except now the runway is located at an angle of 45 degrees. That's harder. There's no doubt. If you can't stretch your imagination for this one, you won't be able to stretch your imagination for that one. However, I'll give you a hint. Some of you are actually very bright, and I would hate for you to leave without having a hint. Because, I want you guys to understand it's okay to be smart, but I think your definition of smart and my definition of smart are probably different. I think you guys have been told you've been smart a long time, but I'm expecting you to do smart things. The runway is at an angle now. So let's imagine that the runway is, say it's right here. There, angle 45 degrees. That's hard because you want your plane to deal with the fact that the wind is this way and you want to land down the runway, which is also at an angle. You can't zero out one of your answers, which is how we did the last question. We zeroed out one of the answers, right? Whoever said you had to make north the y direction? I never said that. I've tried to impress upon you that we can do whatever we want with our coordinate system. So I'm going to shift it so that it's lined up with the runway. By doing that, I have to understand that I've also shifted the wind relative to my new coordinate system. Right? I turned my coordinate system 45 degrees to line up with the runway. So now my wind is 100% in the negative y or negative x direction. Point your plane. Just understand that when you go to point your plane, you're probably going to point the plane somewhere like this in order to get your answer. Your answer still has to be relative to north, south, east, and west. So when you're done, you'll have to rotate your axis back to north by making a comparison with this angle and the 45 degrees you shifted your axis. That's tough, though. That's really tough. I'm not expecting many of you to be able to do that. I expect you could follow number 6, though. I am expecting that.